can join. I think I'll begin the day with your date, because today is a little special day. So I would definitely like to mention about it, especially in present day context. These things become important now because all of us are at home and people are not having the usual social interaction in schools and colleges, which is important for your age group, and therefore it becomes important to remind you that you should be, taking care and looking after your emotional well-being also. And I'm keeping that in mind today by not doing excessively overwhelming questions. So I'm trying to look at today's class being a little happy and making sure everybody is getting all the questions on their own. So that is a small way that I would want to celebrate SARE Day. But otherwise, I think, yeah, every day this is important. But just that these special days give us a little bit of reminders if we are forgetting about these things. Okay. We have, I know we yet have to practice, but we have understood trigonometric substitution and simple substitution method. At least we know now how to proceed. We will be doing more revision questions, but we will go to the next method, which is, and there is one more method called partial fractions that I have to do, and that will finish your syllabus for the June exam. So from April 1st, I want to revise all the things that are there for your June exam. So then I'll get about 2 weeks time to do that. So in our regular classes, I will revise the portion, and in the additional class, that is the 2 to 3 class, I will do the paper 3. So that way you will have a little bit of idea on how do you prepare yourself for the June exam in your summer break. Okay. So let us start with the next method for integration, which is called integration by parts. And before we go to the method, I would like to remind you of the product rule, because the integration by parts rule is coming from the product rule. We know that integration is anti-differentiation. So everything that we do in integration actually is inspired by the method from differentiation. For example, that integration of simple substitution was an exact reverse of chain rule. I'll just show you how. So if I have a derivative of a composite function, what do? I write the derivative of the outer function times the derivative of the inner function. I'm sorry. What happened, Chirag? I'm not able to hear you.
I'm sharing your screen.
Yes, I'm sharing my screen. Are others able to see the screen?
Yes, ma'am.
Okay. Chirag, you want to log out and join in? Okay, so I was talking about chain rule. If we look at this expression, I have a function and its derivative. This is what we look for when we do substitution. If I was given integral of cos x cube into 3x square, the substitution that I would look for is that let x cube be u, and therefore 3x square dx will be du. And so my integral will become integral cos u du, which is nothing but sine u, and u is x cubed, sine x cubed. So I got back, right? So the idea of simple substitution is inspired by chain rule in derivatives. Same way the idea of trigonometric substitution is inspired by the, one is the derivatives of trig functions and the other is trig identities. that we use. Same way, trigonometry integration by parts is done by understanding the product rule. So let's go back and look at what the product rule says. Can somebody, Karthik, can you tell me what the product rule says in derivatives?
Wait, in the UV form?
Yes.
Ma'am, is it U dash V plus derivative of U into V
Okay.
plus the derivative of V into U?
Very nice. Okay. And here order is not important, right? Because it's just an addition and multiplication. So I can do it in any order. It doesn't matter. So I can say U times derivative of V plus V times derivative of U. Another way to write this is U V dash plus V dash U. This is symbolic, that V dash and U dash are symbolic of first derivative. Correct? Now, let me rewrite this whole thing. If I take integration on both sides with respect to x. So I am taking integral with respect to x. Oh, sorry. I wrote something wrong here. Correct? I'm just taking integration on both sides. And we know integration and derivatives are inverse of each other. Integration and derivatives are inverse operations. So they are going to cancel each other on the left hand side. And what my expression will become is u times v is integral u dash v dx plus integral uv dash dx. Okay. What integration by parts tells us is, if I have the integral of a product, okay, if I have integral of a product of two functions such that one of them is easy to differentiate and another is easy to integrate. Listen to me carefully. If I have integral of a product where one of the function is easy to differentiate and another is easy to integrate, say u was easy to differentiate, when I differentiated it becomes something simpler, then I can rearrange this and say I am not doing anything, I'm just rearranging the terms. Now how is this going to help me? That is something I want to find out using examples. Right now this formula will seem completely abstract to you, saying that okay, you have rearranged the sides of the equation, so what have you really achieved? Let us see what have I achieved. So all I'm saying is I started with the product rule in derivatives and I integrated both sides and rearranged my function, my equation to look like this. Let me see how is this expression going to help me, and this is my expression for integration by parts. Let me start with some examples and then we will. So what type of functions are solved by integration by parts? The integrals which are product of two functions. So I'm starting with an example where I have integral of a product of two functions. Mirna, can you identify the two functions which are being multiplied? Mirna, which are the two functions that are being multiplied?
E to the power of x and...
Okay. And?
I'm not sure about the other one.
Ma'am, the other one is just x.
Very good. Very good. One is e raised to x and the other is x. Absolutely. So I have a linear function or an arithmetic function and an exponential function. Now I have written u, v. So which one is u and which one is v? How do I decide to make it simpler for myself? So the rule says ILATE, where I stands for inverse functions. Which are the inverse functions? Like your trig equations, trig inverse functions. L stands for logarithmic function. A stands for arithmetic functions. Arithmetic functions are all your x cube, x square, all your power functions, polynomials are arithmetic functions. T is trigonometric functions and E is exponent. I will choose u. I will choose the function u in this order. In which order? In the order of ILATE. So if I have two functions, the one which is ahead is u. For example, here I have an arithmetic function and an exponential function. In my ILATE, a comes before e. Therefore, x will be u and e raised to x will be v. And I will justify. You may think, how come you can come up with any rule like that? I'll justify why I'm doing that. But right now, you will have to trust me with this rule that I'm going to choose u in this order. Whichever function is ahead in ILATE is the u function. Okay. So, according to integral by parts, I'm first supposed to choose a u, which is my x, and I'm supposed to choose, obviously the other one will become v dash then, because I want to find the integral of u v dash. So your v dash is e raised to x. So what is u dash then? Because if you look at the right side, if I want to find integral of u v dash, I need u, v, I need u dash, and I need v. Okay. So I have u, I need u dash. What is the derivative of u? 1. Because u is x, derivative of x is 1. What is the integral of v?
E power x, ma'am, right?
E power x only. Now let me rewrite everything in the formula. What does the formula says? Integral of u v dash is u into v. What is u? U is x. V
Ma'am,
is,
what would
yeah.
be plus c?
Sorry, why did we not put c?
X. Yeah, why did you not put c?
No, I'm going to. I just didn't write it in that formula, but I will be using integration constant, sure. But thank you for reminding that. So it's u into v minus integral of u dash into v. U dash into v. So the reason I have not put c in the formula is because I have not yet finished my integration. I still have an integral to do. But in my question, I am going to put a c because I'll finish my integral. So x e power x minus. Now is it easy to integrate this? Yeah, it's only e raised to x. An integral of e raised to x is e raised to x. Now I'll put a plus c. I didn't have a plus c in my formula because I left it in the integral form. I'm saying integral of u v dash is uv minus integral of u dash v. So that's my final answer. If I integrate, if you want to check, did I do it correct? Differentiate this and see if you go back. If you have any doubt, that's how you used to do it in middle school, right? When you used to have a doubt, did I solve the equation correct? You would substitute that value that you got in the equation back and see, is it satisfying the equation or not? Same thing let us do. Let us differentiate this expression. If I get back the original expression, then I'm right. What is the derivative of x e power x? It's product rule. What is the derivative of e power x? E power x only. Derivative of c is 0. Have I got back my original expression? Yes. So my integral is correct.
Ma'am, I didn't understand the derivative part. Can you explain that again?
How I checked, I'm saying if I find the integral of an expression, then if I take derivative, I should go back to that expression, right? Because derivative and integration are inverse operations.
Yes, ma'am.
So if I find a derivative of the answer, shouldn't I go back to my original question?
Yeah, ma'am.
That's all I'm doing. I'm just making you verify whether my method is correct or not. So how did they come up with this islate? Well, they came up with this islate because they found that when I chose U in that order, I was always making things simpler for myself in comparison. So let us take another example. Integration by parts is always used when I have a product of two functions. Do I have a product of two functions here?
It's just one, right?
Ah, okay. So you feel that it is 1 times ln x? Okay.
Yes.
Let's take that. So I have two functions. I have a 1 and I have a ln x. Let me look at my islate and check what type of functions do I have. What category will 1 fall under? Which function? Is it an inverse, log, arithmetic, trigonometric, exponential? Which function is it?
Arithmetic.
It is arithmetic. Arithmetic will include all polynomials. Polynomials can have constants also. So 1 is an arithmetic function. What about ln x? Well, ln x obviously is a logarithmic function. So which one will be u?
Ma'am, ln x.
Very good. The one which comes in the first, right? In that order of islate, whichever comes first is u. So u is ln x. And then what is the other one? Obviously the other one is v dash. Because I am finding the integral of uv dash dx. This is what I am finding the integral for. Okay, so I need, but what is the formula that I look for? Integral of uv dash dx is u times v minus integral u dash v. So I need u dash also and I need v also. So let me find out u dash. What is u dash? What is the derivative of ln x?
1 by x.
1 by x. What is the integral of 1?
X.
X. Very good. So my formula becomes u into v. U into v minus integral u dash into v. Fantastic. Became so simple. I know what is the integral of 1. That's my answer. And if I want to verify, please take derivative and see if you get back ln x. If you have any doubts whether this is the integral of ln x, then take the derivative. So I'm going to take the derivative x ln x. X times derivative of ln x plus ln x times derivative of x minus derivative of x plus derivative of c is 0. So 1 minus 1 is 0 and I'm getting ln x. Yes, so my integral is correct. So this method is kind of making sense. And it is also falling in line with what I learned in derivatives. It is the product rule that has just been reversed. So I think I'm doing everything in line with whatever I have learned till now. Let me take some more examples before I'm too sure whether I'm doing it right or wrong. Okay, I'll give you 2 minutes. Please think about it and then I'll start doing it. So I'll write your islate for you and I'll also write the formula for you. Take a little while. Don't give out the answers. Let everyone think, please. And let me see who is going to answer this for us. Okay, Arav, I think you can do that. Can you identify U and V dash for us, Arav? What happened to Arav? Okay, Rohit Serigiri, can you identify U and V dash for us?
Ma'am, here U is X and
Okay.
V dash is sin X.
Okay. What type of functions are X and sin X?
X is arithmetic and sin X is trigonometric.
Very good. So in this order, if we go, he's right in identifying U as X and V dash as sin X. Now we know in our formula we need V as well as U dash. Smriti, can you help us? Can you tell us what is U dash and what is V? U dash means derivative of U and V is integral of V dash. Smriti? What happened? Smriti is also not there. Sayuj, you can help us? What is U dash and what is V?
Ma'am, U dash is basically 1 and
Okay.
V is gonna be cos minus cos, no, yeah,
Yes.
minus cos X.
Yes. Minus cos x. Derivative of cos x is minus sin x. So integral of sin x will be minus cos x. Correct. So now let me put everything in the formula. U into V minus integral U dash into V. It has made things simpler, isn't it? Now I am coming across the integral which is so much simpler than what it looked before. And why are we doing all this? Well, we don't have product rule. We don't have quotient rule. We don't have chain rule integration. So we need to simplify every expression that we have in a form that I recognize what to do. That is the reason we are having so many methods in integration. Integral of cos x is sin x plus c. And if you have any doubts whether this is correct or not, you can take derivative of this expression and go back and see, do I get back my original expression? Let me see. Derivative of minus x cos x. So it's minus x times derivative of cos x plus cos x times derivative of minus x plus derivative of sin x, and so minus cos x and plus cos x cancel and I'm left with x sin x. Yes, that's the expression I started with. So what I did is correct. So this formula is working well, right? And this rule, Eilert rule, is also helping me because it is making things simpler for me. Great. Can we challenge ourselves slightly? Okay, let's.
1 second. Man.
Yes,
Move it
yes.
up, like,
Sure.
just want to see. Yeah, man.
Okay. Fine. Let us do something. A formula that we had already derived before. Let us now do it with parts. So if you remember integral of cos square x dx, what method did we use before? Pranav, can you remind us which method did we use to find integral of cos square x?
Ma'am, using cos 2x.
So I wrote this as 1 minus cos 2x upon 2.
Yeah.
Okay. 2 cos square x. Yeah, okay. And then I solved it, right? So I got x by 2 minus 1 by 4 sine 2x plus c. That was my answer. Fine. I'm going to see if I can use integration by parts for solving this. I'm sorry, give me a minute. I'm extremely sorry about that disturbance. Okay. So I'm going to write this cos square x as a product. Can you please try? Now tell me, in my Eilert rule, both are the same function. So which one should I take as u and which one should I take as v dash? Maybe it doesn't matter. Let's see. Let's try. Does it work or not? So I'm going to take cos x as u and cos x as v dash also. So u is cos x and cos x is v dash also. So u dash is minus sin x and v is sin x. Okay. So my integral, my formula says integral of uv dash is u into v minus integral u dash into v. U dash into v. Okay. And what was I integrating? I was integrating cos square x dx, if you remember. Okay. So my integral of cos square x dx is sin x cos x plus integral of sin square x dx. Not yet achieved anything. Okay, but let me write this further as plus, I'll write sin square x as 1 minus cos square x dx. Okay, and then split this up. Oh, I have the same term, so I can collect those two terms together. So I can write this as 2 integral cos square x dx is equal to integral of 1 dx is x plus sin x cos x plus c. Therefore, integral of cos square x dx is x by 2 plus sin x cos x upon 2 plus c. You don't need to divide c by 2 because c is that constant after everything else. Is this the same answer that I got? Yes, I got x by 2 plus 1/4 of sin 2x, but sin 2x is 2 sin x cos x. So what I have got is same as what I got earlier. So this is another way for me to show you that integration by parts works because I got the exact same result that I got earlier with another method. You can try integral of sin square x similarly. If you're confused by this method of how come I gather the two terms together, well, I always do that, right? In equation, I always collect like terms. Even if it's in integral, how does it matter? Integration also gives me finally some answer, which is an algebraic or an arithmetic term. So
Ma'am, could you scroll up a bit?
Yes. Yes. Anything that is not correct?
Ma'am, I have a question.
Yes.
So you said that for the IL-8 mathematicians just decided because it was working well, but is there like an actual mathematical explanation why that process works?
Right. That process works because in that order, when we choose the functions which are ahead, right, those are easy to differentiate. Then the function is, so if I look at the order in which I wrote the functions, those functions are easy to differentiate in that order only. And they are more and more difficult to integrate in that order also. So my rule to choose U is, how do I choose U? What do I do with U? I differentiate U. So I want an order in which functions can be easily differentiable. So that's the order is ILATE.
But isn't arithmetic functions easier to differentiate than inverse functions?
But inverse functions give me, and if I take derivative of tan inverse x, I get 1 upon 1 plus x square. Don't think about easy in terms of you finding it easy to differentiate. The meaning of easy is that it results in some terms which get cancelled with the the second term. So the final expression will become simpler for you. So I want the order in which the terms will become simpler. When I say easy to differentiate, does not, I mean, you may say that polynomial is easy to differentiate. Yes, but the final expression should become simpler for me. So this u dash v should result in a easier expression than what I started with. That's the reason I choose that order.
Okay, ma'am. Thank you.
Yeah. Okay, let's slightly challenge ourselves. Now again, I don't have two different functions. So I will answer Chirag's question. How do I decide which is u and which is v, right? Let me rewrite this secant cube x in a form. Now tell me, Chirag, answer which of these two expressions is I mean, whose derivative and integral you readily know, which will make things easier.
We know the integral of secant square x and
Yes. Yes, in derivative of secant x is secant x tan x, and integral of secant square x is tan x. So the answers, because integral of secant x is ln of secant x is tan x. So the expression for the integral of secant x is quite complicated. Whereas if you take the order as this as u and this as v dash, you are getting simpler expressions from u and v. So that's the order in which I will choose. I will select secant x as u and secant square x as v dash. And what is my formula for integration by parts? Integral of uv dash dx is u into v minus integral u dash v dx. Okay, what is u? I know, but let me find out u dash and v also before I proceed ahead. So u is secant x. So u dash is secant x tan x. V dash is secant square x. Therefore, v is tan x. And let me now write my formula. So integral of secant cube x dx is u into v minus integral u dash into v. So secant x tan x minus integral secant x tan square x dx. Well, I started with a product, I'm still with a product. Okay, but no problem. Let's see if I can do something about it. secant x tan x minus integral secant x. I will write tan square x as secant square x minus 1 dx. Minus integral of secant cube x plus integral of secant x dx. Oh, this is my question. This is what I have it on left hand side as well. So let me collect these two like terms. So 2 integral of secant cube x dx is secant x tan x. What is the integral of secant x? We have done it now enough number of times. Everybody should remember this.
Ma'am, ln mod secant x plus tan x.
Okay. I hope everyone remembers what Karthik said. Ln of modulus. Is it important to put a modulus when I use ln?
Yeah, ma'am, because you can't have negative values in.
Very good. You know the trig ratios can become negative, but ln cannot accept negative inputs, and therefore putting a modulus is very, very important. Unless you're sure, like for example, ln of x square. X square doesn't need a modulus symbol, right? Because it will always be positive. So unless you're sure that it is always going to be positive, you will use a modulus sign. So have I finished? Not yet. So integral of secant cube x dx is half secant x tan x plus half ln of secant x plus tan x. You know, my first memory of integration is I was in grade 7 and my brother was in grade 12. And he used to have like this long book where he would go on putting this symbol. And his name also starts with S. For some reason, I used to be thinking that, you know, he's kind of putting his initial all around in the book and wasting his time doing things rather than concentrating on math. That's my first memory of integration. I had no clue what that symbol S stood for. I was not even interested in finding out much about it. But yeah, whenever I do integration, I always distinctly remember that long notebook in which my brother would be solving like so many questions of integration. Yes, I know it's not that fantastic as I promised in the beginning of the lesson that I'll keep it little easier and lighter, but this method is, you know, much simpler. Most of the students feel than the trig substitution. Trig substitution is something that majority of them get bothered with. That how do I decide what substitution, and you know, it's only looking more and more complicated. In that sense, I felt maybe integration by parts might be a better lesson to do today. Let's look at some more examples. Are there any questions? No questions? Yes.
No, I was saying no.
No. Okay. Okay. Fine. Let us look at, for example, let me share a worksheet with you. 1 minute. Give me a minute. Some set of questions that you can try and an easier one. Some of these questions we have already done. So look at the ones we have not done and just try. Start. I've shared one on the chat screen just to give a little practice of whatever we have learned today. Look at the sheet and you know, we have done x e raised to x, we have done x cos x. Maybe try with the fourth question. And they have already told you what is u and what is v dash. Instead of v dash, they have called it dv, derivative, but doesn't matter. Try with the fourth question and see if you are able to do it. There are only about 8 questions here. We can just try that so that we know the method and then we end the class. And those who want to go ahead and look at other examples, please go and do it.
Mom, we're supposed to do the fourth question.
Yeah, first the fourth question and then look at any of the other questions that you want to try your hand at. And give yourself a chance to practice that method. Know what is U, what is V dash, and the solution is given in the same sheet, but just give yourself a chance to do it on your own. Don't look at the solution as yet. Vishrut, can you try the 10th question, and when you're done, please explain to the class? Vishrut, you're there? Okay, Vishrut is not there in the class. Varun, you want to do that? Can you try the 10th question and then explain to the class?
Sure.
I'm just going to slowly start doing the fourth question on the board so that you can check. I know the solution is given in the worksheet, but just check if you have got the fourth answer correct.
Ma'am, in the start, isn't it? Okay, UV, okay.
Right? U into V minus integral U dash into V. Okay. Varun, you are ready to give us the solution?
Yeah, no, I'm almost done. Just give me a second.
Okay, so you will tell me the steps and I'll start writing it on the board then. It's just to minus x cos 2x, right? Okay. e raised to minus x cos 2x. Yes. Tell me, what is u and what is v?
I took u as cos 2x and v dash is e power minus x.
Okay, it is according to this. So trig function is coming before that. Okay, great. Then,
So then I differentiated u and integrated v dash. So I got u dash is equal to half sine 2x.
are you sure?
It's a, oh sorry, it's 2 sine 2x, right?
Ah, correct. 2 sine 2x. Okay. And what is
That's minus e power minus x.
okay, great. Then,
And then we just take the formula, right? uv minus integral of u dash v.
so uv minus integral of u dash into v. Okay, then
Then you have to integrate the e power minus x into sine 2x.
yes, so I still have one more integration by parts now. Because this is still a product, isn't it?
Yeah.
So now tell me again, what is u and what is v?
Here u would be sine 2x and
Okay.
v dash would be e power minus x.
Okay.
Then you differentiate, you'll get minus 2 cos 2x.
Hey, by the way, we needed a minus here, isn't it? Derivative of cos is minus sign.
Oh, derivative of cos, right.
Correct. So this will become a u dash into v. So this will become negative. Okay. Yes. And this is it. Okay. So I'm going to rewrite the second part of the integral. Let me call this second part of the integral as I1. So my I1 looks like this. U into V minus integral U dash into V.
You write 2 cos 2x into e power minus x. Now can we substitute all of this into the initial equation?
Yes. Yes. Now we will substitute everything back into the initial equation. So my initial equation is integral of e power minus is equal to let me substitute this back. Now, Varun, what do we do?
You want to clear the minus first, obviously, and then you can take the integral to the other side.
Very good. So we realize this is what we started with. This is what is on the left hand side. And I'm sorry for missing dx. You should never miss that in an integral sign. So what is on the left hand side now is, do you realize how we had to do integration by parts twice? Because in trig functions, trigonometric derivative and integral can be done infinite number of times. Derivative of sine is cos and derivative of cos is sine. It keeps going back and forth. So there is no end to it. That's why you had to do it twice. But once you did it twice, you could gather the like terms together. So it is 3 times integral e raised to minus is equal to minus e power minus x cos x plus e power minus x sin x and sorry 2x, no, everywhere it is cos 2x. Sorry, this is also 2x. And then you divide throughout by 3. That's your integral. That's your final answer. Okay, this is very, very commonly asked question in IB, trig ratios, because of this kind of a repeat integration by parts. It often comes in paper 2, usually because they are extended response questions more in paper 2. But trig functions are the favorite in integration by parts. They're easier also if you once get the hang of it. Only till in the beginning it seems a little tricky, but okay. Thank you, Varun, and I think that's where we end the class today.
Ma'am, what did you use as U?
The trig function, and e power minus x was your